I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hi Matt.
How you doing?
I'm doing great.
So, we don't usually try and make these things in any way timely. We just talk about stuff that is, true forever. But a friend, ex-colleague of ours, recently posted something rather inflammatory about something which is dear to the hearts of many. And my sodding dog is making such a noise behind me. We're going to carry on. I'm afraid I'm puppy sitting.
Yeah, we have a guest on this week's podcast.
A special guest is Monty, who is a 12-week-old black lab and is currently in the pen behind me. Anyway, the solid principles are things that are sort of taken mostly as truth by a lot of people. I'll see it in code reviews all the time. People say, hey, this doesn't conform to solid. And Dan recently posted a blog entry that's sort of taking it down. And we figured we should talk about that. Now, I'll be totally honest with you. I've been a software engineer for 20-ish years. And I don't really know what the solid principles are. I just kind of, people say about them and I'm like, oh yeah, sure, I'll refactor my code in the way that you said.
Right,
so
right. I'm
going to look to you to teach me, first of all, what they are. And then maybe we can talk about some of the things Dan raised. And maybe I know you'll have opinions because you're Ben.
I have opinions. So, this is my gig, is I have opinions.
What are solid?
So let's talk about solid principles. Obviously, all of our listeners can Google solid principles and know what they are. All of our listener can Google the solid principles. But just for those who are, in mid-podcast and don't want to be bothered, they are S stands for single responsibility principle. O stands for the open-close principle.
That's the most confusingly named one for me.
Yes, we'll talk about all these. We're going to talk about all of these principles.
You go through them first.
L stands for the Liskov substitution principle, named for Barbara Liskov, who presented that in a presentation in the 80s, I think, is when she proposed that. I stands for the interface segregation principle. D stands for the dependency inversion principle. So those are the solid principles.
No wonder. I mean, I can't imagine why I never sort of committed that to memory. It seems so obvious in retrospect.
Yes. Right. Of course. The controversy is particularly interesting for me. I never really had the opportunity to work directly with Dan. He was sort of around and about at PrevCo for me. I ran into him a few times and had some conversations with him. It's not like we ever sat down and wrote code together, but, I sort of talked to him and was very interested to hear a lot of his ideas. I did actually work a little bit with Bob Martin when I was at Object Mentor back in the, 2008-ish timeframe. And, as we had the guest on before, James Grenning also worked with him at Object Mentor. And when I was at Object Mentor, the solid principles were definitely part of the, curriculum, I guess I would say, that they would teach in their training sessions.
Right.
And so, that was something that was very much a part of that. And I think Bob is kind of known for promoting those principles as good principles of design. His books talk about the solid principles and stuff like that. So while I don't think that Dan was maybe directly talking to Bob when he was saying the things that he was saying about solid, I think at least he had in the back of his mind, Bob would be one of the people that he would be, if I were framing such an argument, I might sort of assemble a virtual panel of people in front of me and sort of argue with them in my head. And if I were Dan, I would say Bob would maybe be one of those people.
Bob would be another,
Yeah. So I have a little bit of I can see both sides. I've had direct contact with both sides of this war. And so
war is that's a strong phrasing. Let's not phrase it as that.
Yeah, right, I know. I'm being a little funny here. I don't really think that there's actually that much of a controversy here, right?
No, sure.
But I can definitely. I feel like I can argue both sides of this argument. And I have my own sort of take, which is not really in the middle. It's sort of like a third thing off to the side. So we can maybe
Interesting.
throw that into the mix and evaluate that on its merits.
Interesting. But let's talk at least briefly. Let's do like a one paragraph so that I understand what each of those SOLID things. So the first one was what? It was
single responsibility principle.
Okay. That one, I recall something when I was working at Google. It was sort of boiled down to me and transmitted to me, or rather, it's stuck in my memory. And maybe you can tell me if I'm actually right on this one. It's like, if you're writing the description of a class and you use the word "and," then maybe, just maybe, that class is doing too much. So you want to like break it into two classes or something like that. And in my mind, I've combined those with the S of solid. Right, that's what I think of when people say single responsibility. I mean, like, if I can explain what this is doing. It's a price class. It holds a price. Well, there you go. I think that's probably it. But if it's the, I'm not going to come up with any good answers. But if I have to put the word "and" somewhere when I'm trying to describe it,
price
then
and
probably,
quantity, right?
Well, yeah. You see, that's where it gets tricky, right?
No, because you just call that you'd call that an order, or you'd call that like there's another name for that, right?
Well, that's not true. So you've picked. That's a perfect example, actually,
yeah, right.
Unintentionally, because
almost like
it's almost like you thought about this before, but price and quantity is a really convenient abstraction to have in a trading system because you always want to place an order, and an order is not a price and a quantity. An order has a price and a quantity. But then so does an order that's resting in the market. So does maybe your risk limits in some ways are related to these things. There's a number of ways where that tuple of a price and a quantity going together is a useful thing of itself. But it doesn't really have two responsibilities. It just holds two pieces of information. Right. Maybe that's where you're nodding at me like, this.
I mean, a lot of these are heuristics, right? Like the heuristic that you got to Google is if you're putting the word "and" in a class name, think about it, right? Like, are you putting together? And I think a lot of this, there's a lot of, I don't know if this is good or bad, but my experience as a software developer has been a lot of this is almost like an oral history that gets passed around from developer to developer about here's the things you should generally do and here's the things you generally shouldn't. And the interesting thing is that the oral history among a lot of developers turns out to be the same in a lot of respects. And I think single responsibility principle is one of those. It's sort of like the Unix principle of do one thing well. Right? There's a lot of, and you can find other examples of this where it's like, keep things focused, do one thing. But then the arguments sort of come in terms of like, well, what do you mean by one thing? Right?
Right. One thing is a different thing. Because like my price class can also represent itself as a string and it can be formatted and it has all these other things. So like if you were to describe the responsibilities of my price class, it would be wraps the abstract notion of the value of something and can represent itself and perform arithmetic on itself and before you know it, you've got like 100 ands then in a useful class.
Right.
But they're not really, they're not different responsibilities.
Yeah, what do you mean by responsibility?
Is a responsibility?
And what do you mean by single? Yeah, exactly. It's like.
What do you mean by? What do you mean? Is that too much? No, okay.
Right. And I mean, I think that this actually going back to sort of, Dan's comments, I think this is part of what Dan was good at getting at is he was saying, don't worry about single responsibility, just write simple code, right?
Right.
And
it sort of made me think as I was reading this actually of the thing you've mentioned before, the 1 second's worth of like microservices. Like it's really hard to measure how big something is. You have to kind of come up with some heuristic, and you've used time of before now as like how long does the unit tests for this bit of code work? And that's an interesting way of measuring it as well. And
but it's arbitrary, right? Yeah.
To each their own, right?
Yeah.
Right. Reasonable people could disagree about what it means to be small or simple.
Yeah. So for me, the way that I interpret the single responsibility principle is sort of the inverse of another principle that is not in this list, the dry principle. Don't repeat yourself, right?
Right.
Where the litmus test for me is something like this. If my boss comes to me and he says, hey, we need to change this business logic, right? And I, with the knowledge of the code, look at the code and say, okay, but if we change that, then we're also going to have to change this. His reaction tells me whether or not I've followed the single responsibility principle correctly. If I say, well, we're going to have to change this, if he says, oh, great, perfect, that's exactly how it should be, then I know that I followed both the single responsibility principle and the dry principle correctly. I have one place in the code where that business decision is made, and it is impossible for me to change it without changing the things that it depends on. So it's like if that wasn't true, and I changed this, and then 2 weeks later he came to me and be like, well, you changed that thing I told you, but then this other thing broke. I'm like, oh yeah, were those supposed to be the same? He's like, of course they're supposed to be the same. And I go, oh, sorry.
Yeah, right.
Then I haven't followed dry in that case, right?
Mm-hmm.
But if he comes to me and he says, well, we have to change this, and I say, okay, well, we'll also have to change that, and he says, why? That's dumb. Why would we ever change that? Then I know I haven't followed the single responsibility principle, and I've squished two unrelated things into one thing, right?
Understood, yeah.
And so this is kind of the thing with dry, too, where it's like you can have two pieces of code where the code is identical, but the reasons for that code to change is not. And unifying them is actually making your code worse, because now you're in a situation where you change things. You're coupling things together. You change one thing, and you're changing something else that's totally unrelated, and that behavior needed to stay the same while this other behavior changed, right?
Got it.
And you can have a situation where you have two totally different pieces of code that are, in fact, the same thing. And what you should be doing is refactoring that code so that it looks the same and then unifying it, right?
Got it, yeah.
But
you're driving it from a business sort of point of view, from the idea of which obviously not all of us have the same experience of having a direct business owner that can tell you that kind of stuff. But you're kind of like conjuring up in your mind's eye the sort of pointy head boss to measure these things in this sort of slightly thought experiment way.
Yeah. Well, and I personally don't think that it's impossible for me to say, without understanding the context in which a program is going to be used, whether or not, for example, two pieces of code are duplicated, right? You can show me two pieces of code. I can say, yeah, that's the same code. I'm not going to tell you that you should unify them unless I understand how the code's being used, right? You can't separate that understanding. That's part of an engineer's job, is to be the bridge between the technology and how the technology is being used.
Got it.
So, and I think a lot of the solid principles have to be thought of in that context of how is this actually being used?
So we've covered the S of solid, and I think we've done at least some justice to Dan's point about it meaning many things to many people. And so maybe we should move on to the O.
Yeah.
Which again, I've already forgotten what O is. O is
open close principle.
Open, obvious. I mean, again. Trivial understanding now. With a single letter O.
Yes. Yes.
So what is open closed?
What does the open close principle mean? So that the pithy phrase here is that code or a module or a class or however you want to scope it should be closed for modification but open for extension, right? And the way that I kind of interpret this is if you have existing behavior that you don't want to change, you shouldn't have to change it in order to add new behavior.
Yeah.
Now that's a goal, right? You're never going to be able to achieve that 100% of the time, but to the extent that which you can do that, what this principle is saying, and I'm not saying that this is necessarily true, but what this principle is saying is to the extent you can do that, you have produced a better design. Design A is better than design B because it is easier to extend and you don't have to modify. Right. Now, this is a place where I have a lot of sympathy for Dan in that, a lot of what people sort of get into with this is reuse, is designing for reuse, right? They want to write code that can be easily reused.
But that isn't always the right goal for anyone.
Right. I mean, I'm pretty short reuse most of the time when it comes to... I like to discover places where things are reused and not try to predict where they're going to be reused.
That's a nice,
right?
That's a good analogy. You discover it. It's an emergent property of the code and the way you're going, but very rarely do you set out and go, I'm definitely going to reuse this. So I'm going to polish this beautiful, reusable gem only to discover it's used in one place in the code. Or indeed, you've hamstrung yourself by making it so difficult.
I often wonder if there's a strange legacy in programming where it's in the beginning, there was ones and zeros. And then we invented languages, right? And so, a lot of programming, this sort of oral history comes from the problems of language designers, right? Mm-hmm. Because that was sort of the beginning of programming, right? Of the design of programming languages. And a lot of those problems that language designers face sort of got held up as the important problems to solve When really, if you're just building like application code or even certain systems code, like that's not really the main problem that you have, right? Like a big problem for me isn't creating a reusable standard library that is easy to use correctly and hard to use incorrectly, right? Like that's not a problem that I solve. Occasionally I do, but not very often, right? Whereas, if you're designing a language, that's a lot of what you're doing.
Of course.
Right? And so, to me, the open close principle sort of falls into a little bit into that category, which is, it's useful in certain situations, but I certainly wouldn't make the claim that code that follows the open code principle is just always better than code that does not.
Got it. This definitely falls more under the sort of guidelines for measuring a design, perhaps, but somewhat in a vacuum rather than being specifically in my use case. And from my experience as well, like the tooling has changed significantly, and the way we build software has changed maybe since this. It's not, and OO, which sort of, to me, when I hear that, the open close thing, I'm thinking of like, oh yeah, this is a class where you've got extension points that are like overridable, but you don't necessarily have to. That's obviously one way of achieving that kind of thing, but it smells like that's the way perhaps you would be wafted towards by the. Sorry, that doesn't make much sense, but yeah, it feels OOE to me, and it doesn't have to be. And so, like again, with modern tooling now, if I need to change a piece of code, it's not scary to open it up. I have tests that protect me from like other people's pieces of code, and if I need to just go and change something, I can go and change the code and or use a refactoring tool to add things. All these things are in there, so it doesn't seem as frightening. Now, if I was publishing a library and it was v1.2.7, then I'd have to think about it, which I suppose goes to your point about not all of us are writing libraries all the time. Most of us are just trying to get the next version of your app or your code deployed, and code reuse is not such a big deal. But obviously, a good design still can be beneficial, right? If you start out with a giant list of strings that everyone has to kind of edit in 3 places to add another string in order to extend your library and make sure they all agree, that's a bad design measured by any axis, right? So if you, Yeah,
I think at a certain point, application of the open close principle in most contexts just devolves into decoupling, right? And this is again kind of getting back to Dan's point about like just write simple code, right? Like, okay, I think it's a little bit more nuanced than that, but the open close principle really, when you get down to it, is just things should be decoupled from each other so that you don't have to change things in 4 places, or if I'm reusing a function, I shouldn't have to read all the guts of the function to understand how it works or change it, or all of that stuff. But I think that the main application is, like you say, like, if you're building a library or something like that, you really want to think about it. If you're building a library that is going to be used by somebody that you will never meet, as opposed to someone else in your organization, you want to think about that. But it's just that one is much more about context, I think, than the first one.
I mean, just in defense of like the library writing thing, I'm just going to very briefly. Every now and then I've prematurely created a library, shall we say, and designed it a little bit more than it perhaps needed to do. And probably 1 in 50, 1 in 100 times I've done that, someone else has discovered it and gone, oh, this is useful, and then used it for things that I didn't originally plan it for it, which is great.
Right.
But I don't think the benefit of people finding those libraries and then using them and then emailing me and kind of going, yeah, thanks for that thing, by the way. We've been using this all the time in our side of the business. And, oh, that's great. Wonderful. But that doesn't outweigh the pain and suffering that one goes through trying to design for something where you're trying to invent a customer you don't have to design your software so that that customer can reuse it.
Yes. Speculatively doing that is like,
it's a tax and it's expensive.
It is. It's way more expensive to write library code and reusable code than it is to write something that's like more application focused, for sure.
So then L.
Yeah, L.
Liskov substitution.
Liskov substitution principle.
Which means you can switch in Barbara anywhere you like.
Yep. You can. Any Barbara-shaped object can be replaced with a sub-Barbara that is equivalent in every respect. No, I actually don't know if this is true. I was trying to figure this out when I was reading Dan's thing of like, I have heard that Barbara Liskov proposed this as an argument against inheritance. She was like, if you were going to make an inheritance system, it would have to have this property, which is a ridiculous idea. So inheritance, therefore, is a ridiculous idea.
Oh, it was a reductio ad absurdum. The unfortunately was just went, and we have to be absurd then.
Yes. Maybe one of our listeners can point us to a reference on this, because I was trying to find out whether or not I've heard this. I don't know if it's
You've
true.
heard it right.
I want a reference that says that, that's what Barbara Liskov meant when she did this. And so it's super ironic that it's in the middle of this list of principles. This to me is something that is very much about object-oriented design.
Mm-hmm.
If you are writing code in a functional language, this is not something that you ever really think about. Maybe a little bit in corner cases, whatever, but it's certainly not risen to the level of this is what it means to write good code, right?
Mm-hmm. Mm-hmm.
So, it's the basic idea here is that, if you have an interface, if you have an abstract class, and you have a subclass or a subtype, then the behavior, and the definition of behavior is a little bit nebulous here, but the behavior of those subtypes should be indistinguishable, right? So you can swap out any subtype and you get the same behavior, quote unquote.
That's where, I think I understand where this is going, but that description or descriptions like that are inherently extraordinarily confusing to my pragmatic day-to-day use of subclassing and interfaces. Like, the reason I have an interface is so that I can have things that do very different things.
Right.
When you call, what is your name? They don't all say, I am an animal. They go, I'm a dog or I'm a cat, because those are the only obvious ways, or circle lines. Pick your OO standard class hierarchy.
I think it is kind of important to say that, like, this is from the caller's perspective. Right.
Okay.
So it's if the internal state of a class changes differently depending on which subtype it is, like, that's completely fine. But that's hidden away from the caller, right?
Right.
They don't know that anything is different.
So from the point of view of the contract between the caller and the callee, there should be no sequence of events without reaching exogenously to the file system and kind of going, did you write a file or whatever? Yeah. I shouldn't be able to puppeteer an object that I've been given and work out what it is just by using the API, the caller's API.
Yeah.
They look the same, right? It's not like you go, well, if it's this type, you have to call free. And this one, you don't have to call the free thing because, hey, it doesn't matter because it's not actually allocating anything. So you're like, no, you always have to call free, even if it's a no-op in the derived class or whatever,
right.
Because you have to treat them all equally. You're not allowed to go is instance, for example.
Right. Yes, exactly.
Which is the hit the back door that we all end up having somewhere.
Sometimes. I would never do that all the time.
No, of course.
I only do that sometimes. Yeah, and I think Bob would say, in fact, I know that Bob would say, because he's written about this, that this is much more about polymorphism than it is about inheritance, right? And you can have this property in languages that are not strongly typed. You can have this in languages like Python or Ruby or
I was going to say, it smells like duck typing.
Yeah, it can be duck typing. Pragmatically, in strongly typed languages, this often comes down to like function signatures. Like, things can't be following this principle if they don't share the same function signature, or method signature, because then you have to know which one you're calling and pass it the right arguments. But, again, I kind of see this as an artifact of object-oriented programming with a lot of inheritance hierarchies, which I tend not to use anyway, and a lot of polymorphic behavior, which I use sometimes, but again, it's like, does this really rise to the level of like the top 5 principles that you need to be aware of when you're writing code? Like, no, not really.
No, it seems not. Yeah. I mean, there are equivalents in functional languages, right? Matching on different aspects, I suppose you could argue, is a sort of polymorphism, like you depending on these things. But yeah, you're right. It seems very specific to a particular popular in the 90s programming paradigm.
Yes.
And it made a nice, neat backronym fitting L in the middle of an otherwise cool,
exactly.
Soid. It would have like, what? No one's going to want my Soid properties.
Yep.
Find
exactly.
an L.
And so that's and the thing is that it only gets worse from here, right? As we keep going through
we're scraping the barrel of letters.
Yes, we started strong, and now it's like as you go, like it gets even more and more like this is very clearly about a very particular kind of object-oriented design that, again, if you're still doing that, then, you probably know these already. But if it's like that. So interface segregation, you're keeping the interfaces. So you have an interface to a thing.
This is the I, right? We're on
I. Yes,
I
we're on
now.
I right now. You have an interface. You want to keep that interface as narrow as you can get it, so that the clients don't depend on things that they shouldn't, and so that the implementers of those interfaces have the least amount of burden in order to implement. Again, this is very much about like inheritance hierarchies and interfaces and
yes and no. I mean, the
stuff.
interface can be a library interface, presumably too. Like hey, my library exposes exactly 2 functions. It has allocate and it has free.
Yeah,
and there isn't thousands of other. And the only reason I bring this up is because something you mentioned there was like to reduce the burden on calling things that you shouldn't be calling on, and it made me think of Hiram's law, which is the law that anything you expose, no matter how intentionally or otherwise, will become relied upon by somebody at some point, given enough users of your class. So like that, reducing the footprint of that seems like a good idea, and that can happen in C libraries as well as C++ or other object-oriented languages. Sorry, I'm very focused on specifics here, but so
no, that's an excellent point. And actually, now that come to think of it, I was making a very similar argument to that in an earlier podcast when I was talking about file system abstractions and mocking. You remember that?
Yeah,
and I was
do
saying
that
constraining yourself to a limited number of file system operations makes it more likely that you can swap other things out, right? If you don't think of something as a file, you think of it as this sort of abstract stream that might be a socket or it might be a pipe, right? Like that is good. I kind of think of that as a very liberal interpretation of interface segregation principle, because it's when they say interface in ISP, I think they literally mean like a typed interface.
The actual keyword interface is probably involved somewhere in
that's
this.
That's what I can be talked off of that opinion for certain.
Okay.
And I think it's more useful. I think it's more useful if you do. And to your point of like thinking of it as more of a general lowercase I interface, not capital I type interface. But I think it's more useful if you think about it that way. But yeah, I was making that exact argument not but a few podcasts ago, so maybe I should.
In the strange time space of podcast.
Yes, in podcast time.
So that's I.
That's I. And then the last one, D, dependency inversion principle. Basically, he's just like, dependency inversion principle is you want high-level things depending on other high-level things, not low-level things.
Right.
And it's like, okay, so if you have let's take the object-oriented example here. You have an interface that takes an argument. That argument type should be probably another interface and not a concrete class, right? Like you don't want to constrain the implementers of that interface to say that they have to take this particular concrete class. You want them to depend on a higher level abstraction, which is, again, an interface or an abstract class even, rather than a concrete class, right?
This is where like anyone who programs C++ is going, we try not to do that, or like there are various reasons why not, but we've talked about that before. So let's in the abstract, high level components depend on other high level components rather than reaching down into the guts of the class hierarchy and having this sort of I guess that's the inversion of the dependency inversion, is like having this dependency on a low level thing, which then maybe depends on a high. I cut you off halfway through the explanation, and I'm confused now.
Well, I mean, I think this is the least clear of all of them, and this is probably the place where I agree most with Dan.
Right,
just like just write simple code, right? Like it really isn't anymore. There's not much more to it than that. Now, that's my personal opinion, but I think especially for all the reasons that you were just talking about of like in the C++ world, there's lots of other ways to solve that problem rather than creating higher level interfaces. Templating, for example, I think could be potentially used there. But this is the thing where I think I agree the most with Dan, and I say, okay, just write simple code. So for me, the solid principles are like, they start off real strong. S, single responsibility. Yeah, totally get that. I use that all the time. Makes total sense. Open close principle. Yeah, in certain contexts, that's really kind of valuable. List scope substitution may have been a prank. Interface segregation, only useful in very specific situations, and
Right.
I don't really find myself in situations anymore. And dependency inversion, it's like, yeah, I just don't care. So really, the solid principles should just be like, so?
Yep. And even the O is kind of like I sort of like
Yeah.
90% match on the
question
S.
mark, right?
Yeah,
It's-
right. The regular expression of this acronym. Yeah, this is. I mean, I was
Yeah.
going to say this is why we don't have books, but you do have books. But you don't. I don't believe you've backed up any of your books with complicated bacronyms.
No, I do have one actually.
Oh,
I do.
Go on. You
I
can.
have one.
Relevant or not?
The fire principles.
Oh, you do, yeah.
The fire attributes, I guess. I did do that. I mean, I was a consultant. You have to. Literally, that's your job.
That is your job, is to come up with
It's in the job
pithy-
description. You have to come up with the pithy. You got to get people to remember it, right? And, people don't remember what you do and they don't remember what you say. They only remember how you make them feel. And when you make programmers go, then they feel something, right? Otherwise, they're just... They
Wow.
don't feel anything, so you have to
This is where
drive
I've
it
been
home
going
with
wose
those sort of really terrible puns. That's the key to
that
teaching
was the sound of a
programmers.
pun, right? Because I was going to say most developers I meet do make that sound, but then usually it's frustration at me and something I've done.
No, well, no, that is happy sailors complain. Have you heard that?
No.
Yeah, if your sailors are complaining, they're happy, and if they're silent, then you're in a lot of trouble. There's
I
about
see.
to be a mutiny. But as long as they're complaining, they're happy.
That's
right?
yeah, right.
Yeah.
Yeah, I think that does make sense. Sadly.
That's the programmer mindset I've seen
Right.
many, many, many times, and had many, many, many times. So that's I mean, that's sort of the quick run through of Solid
Of
and
what
at least
Solid
my
is.
take on them.
And
Yeah.
I think we've mentioned a few of the things that Dan brought up in his article along
Mhm.
the way, and I mean, I basically because again my understanding of the Solid principles wasn't very strong. Other
Wasn't
than
very
like
solid.
the S wasn't. Yeah. Wow.
Ah.
There you are. Now I'll remember because this is how you made me feel. No, because my understanding wasn't that good. The article made sense to me just of its own because it was making good points. But I think I've got a better understanding now. But were there any parts of of Dan's article that we haven't covered?
Possibly. I read it earlier today. and
Yeah,
I feel like
we
I
don't
should
have
go
to
back
read
and
through the whole thing.
reread
It was more a question of me wanting to pick your brains about what Solid was so that I could have a decent understanding. Because I
Mhm.
think I've long had this feeling that I'm not as real a programmer as most people because I spend most of my time in the weeds down in the lower levels of the technology stack, and there you got a free pass for a lot of the good design principles, all in the name of performance. Yeah,
right.
we don't use this because that would be too slow. And
Right.
I mean, I'm spending more and more of my time realizing that the things that I say like that are not actually true anymore. But it has definitely given me about a 15-year free pass out of good solid engineering principles, high level engineering principles. So I suppose I'm a little bit behind, and I'm now just abusing the fact that we have a podcast to learn from you, which doesn't seem like the worst
Yeah.
worst idea for me personally.
Well, I mean, I think a question you could ask in general, are programming principles a good idea at all? Right? Do they hold up over time? Is this a good way to teach people? Is this a good way to mentor people? Is to have a set of principles that you say, this is what represents good software design. And I think I could maybe argue that the answer to that is no. I could definitely argue that the answer is yes. I mean, I professionally argued that the answer to that is yes.
But then your
But I
paycheck was somewhat independent of people believing you.
Right. Oh, no, really? Okay, well, then we don't need to hire you, and that's the end of this conversation, right? And I mean, I can argue. I think I can argue both sides because I can definitely see merit to both sides, right? Getting back to the whole so there is a technique. This is not a principle. This is a technique that I have used quite a bit when I am trying to teach people how to mentor. So mentoring mentors,
Whoa.
right? And it's called shuhari, and it comes from, I think it comes from a martial art. I'm actually not sure on the etymology of this word, but or this phrase.
Entomology, the study of insects. I think etymology.
Etymology, yeah.
You're not sure about these insects.
Unsure about the etymology of entomology. So etymology. And so Shuhari is this basically 3-phase model of mentoring where you give people Shu is the first phase, and you give people a rote series of steps to follow, right? So you say, do these things, right? Ha is the second phase where you start to help them. They start to see patterns, and you start to help develop patterns, and you name the patterns, right? Like, and literally in software engineering, we've had the patterns movement and other principles like this, where you say, these are things that tend to happen, and this is what we call it when that happens, right? And then people can start to mix and match those patterns, and they see the world in patterns, and they start to recognize them. And then Re is when you sort of move beyond that, and you start focusing on outcomes, right? Like, you don't worry about the patterns, you just think about, this is what I want to achieve, and you have enough experience and knowledge to just know how to achieve it, right?
Yeah.
And the interesting thing about Shuhari is that it is a Shu level technique. Follow these steps and you will achieve this outcome, right? So when I'm teaching people how to mentor, the first thing I usually teach them is Shuhari, right?
The Shu of the Shuhari.
The Shu of the Shuhari, right? And so that second phase, I think, is where these kind of principles have the most value, right? Because you're trying to get people to move beyond the sort of rote copying of do this, do this, do this, do this, to starting to see what's going on and see the patterns. And being able to name them lets you talk about them. Because if you don't give them names, and it's, remember that thing that we did the one time with the blah, 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 and you're 15 minutes of the conversation before you got into the point.
Absolutely what the Gang of Four Patterns book gave me. It gave me a vocabulary to describe, even if we weren't using them very often. But you could just say, hey, that thing, that's a flyweight. And then you could have a conversation about why it was a flyweight. And super useful. But this makes a lot of sense.
Yeah. So like, once you have those names, and it's like in electrical engineering, you have a resistor, you have a capacitor, you have a transistor, right? Like you don't have to describe the properties of a capacitor every time you want to talk about,
and
plates.
Indeed, when you're like doing like EE 101 type stuff, you're just like, yes, you put a resistor. It's always a 220 ohm resistor next to the LED because and it limits the current, and then you just move on with it, and you say, you just do that. Yeah, forget about it. In fact, you'll see, I've seen some people online with they just make these LEDs that have the 220 ohm resistor like on the leg of the LED, so they can just plug them into them but never blow them up, right?
Yeah.
And then later on, you're like, well, what's the principle of that? Well, it'll explode if you put the full current through it. And then later on, you're like, well, I know, I understand what I'm trying to achieve. I'm just going to, I don't even need the light. So I don't need the resistor and I don't need the LED. I'm going to lick my finger and put it on the, that's on now.
That's
whatever.
It. That's it. Exactly.
I'm trying, not the best analogy.
Yeah. Yeah. So at each phase there, you can kind of get stuck in a little bit of a cargo cult, right? Where if you're just following a pattern and you never really, or you're following the steps and you never.
If, for example, somebody's livelihood depends on you following the things that they're saying, then one might argue that there's a certain, not so much a cargo cult as like a willful recycling of ideas, which I know we've got ideas, we've talked before about how we do this, this process of determining what we're going to talk about. We've got some of those things on our list, so I don't want to go into that now. We've got not enough time left to start on that whole world.
Yeah. Yeah.
But I mean, so these are like the eddy currents that keep you in one of your little things, because there's the agile world that says, no, this is how we do things around here, and there's a benefit to being able to talk about it, but then, as you say, it could be a limitation.
Right. There's lots of parallels with lots of things, and a lot of it comes from expertise, right? Like, if you are observing something that somebody does and you start to hear them talk about things in terms of patterns, but you don't understand what those patterns are, you can actually subtly reinforce that sort of pattern style thinking, because that's the only mode that you have to communicate with them, right? You say like, oh, shouldn't we add a resistor to the LED? I don't know anything about resistors or LEDs, but that worked at my last job, right?
Yeah, you're like, no, but
unless you really understand why it is that you're doing that, then it can be the organizations can reinforce this, managers can reinforce this, all kinds of things can sort of, standards committees and certifications and all of these. Are you a Scrum certified blah, 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 because you do these steps and those steps and this steps, right? Like, all of those things can be reinforcing to sort of keep people, to sort of hold them back and like never let them progress to the point where they are letting go of the patterns and just focusing on outcomes.
On the outcome. Mm-hmm. Yeah, that's a really powerful way of thinking about it. But and again, it's not like this is a bad thing necessarily. It's a natural progression
Yes.
I mean, I'm just thinking about silly things like learning to drive. You know, you get in the car and your driving instructor says, do these things. Question not why we're doing them. You know, one day you'll realize why. And I mean, particularly in the UK, when I was growing up, actually one of my best friends was his father was a driving instructor. And there was all these things that we would have to do, like passing plates. As you turn the steering wheel, you always have to have one hand on the steering wheel, which means that you're essentially got your hands at the like 10 o'clock and 2 o'clock position. And then you kind of move up and then you pass it and then you put your hands back down and you're kind of like shuffling around to turn. And then of course he would drive me home, or he'd drive us home, me and my friend home. And he would like have one hand on the top of the thing, spinning it around with his palm or letting go of it entirely. I'm like, Clive, what are you doing? And he's like, yeah. Forget what we teach you these things because that's what we're expected to teach you, and that's what's going to pass the test. And there is foundation in why. There's a reason in why of those things, right? It's because if you are uncertain of the road that you're driving on, you hit a pothole and you haven't got both hands on the wheel, or at least one hand strongly on the wheel, then the car could jump and disappear off. And if you're traveling at 40 miles an hour and you're not able to keep it straight, you're in trouble. So we just teach you this thing. Later on, you'll be changing your shoes in the car while you're late for a function, while holding the wheel with your knees and pulling the choke out in the manual car to keep as a poor man's. Yeah. I mean, friends of mine have done these such things, right? So but you learn to judge the situation based on the experience and what the outcome is, which is hopefully not your impending crashing into a tree, and your right. But so that makes sense to me, and again, when you get like somebody coming new into a team, you're like, hey, this is how we do everything. And then hopefully you have a period of time where they say, all right, we'll just go along with what you're saying for now. And then I'll get a feel for the whys, which may not be as easy to communicate. Then we can have a discussion about I observe that you do these things together. Why is that? Oh yeah, we've had this problem once where we deploy and then we had to back it out. So we also make sure that we can do this. So every time you do a deploy, you always immediately wind it back just to prove to yourself that you can do it, or whatever the technique is. And they go, what if we can develop confidence another way? And then so on and so forth. I see. It makes perfect sense to me. I like that.
Yeah. So I mean, the solid principles are a way, especially if you're operating in that sort of object-oriented world. And honestly, I kind of feel like they almost apply more in Java than they do in C++. Like they sort of came out of the 90s. And I feel like, I mean, obviously Bob and those guys are very well experienced C++ programmers, so it's not like I'm saying that they're coming from a place of ignorance on this. But
no, of course.
But I maybe would recharacterize this as it's in a lot of ways easier to apply those principles as written in Java, right?
Yes.
Like it's much clearer, and maybe that's a nod to Java, and it's was based on the design of things that at least at the time were novel and good. But it's something where unless you're doing that particular style of software development, it's just so.
Ha ha!
I don't know. Again,
well, I mean that seems like we can't beat that now.
A mic drop.
This is definitely a mic or a mic wallop, as I keep walloping my mic on its funny stand. You can probably hear.
Yeah.
No, that's awesome. Yeah. Well, now I know what the solid principles are, and I know that I can disregard the lid. Drop the lid. Take the lid off solid.
Drop the lid.
We can make some more puns.
Yeah. Right.
And we know that the open-closed principle or open-closed principle really just means write easy to understand code that's easy to change. And the single responsibility principle, I think you praise it as write easy to understand code. So what I'm really hearing
maybe
is
a little more nuanced than that.
No, it's just, I mean, write straightforward code. And that's almost always the right thing to do, right? If you're faced up a decision, it's like, which one's the easier one to do? And most of the time, it's the easier thing to do. And
if I were to quote Bob, I would say, yes, write simple code all the time. That is what you should do. The solid principles can be a way to achieve that if you know how to apply them correctly.
That sounds like a great way of explaining it, and a great way to finish the episode too.
Sounds good to me.
So, catch you next time.
Yep.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP. Theme music by Inverse Phase, inversephase.com.